Jain to all. Myself Pancham Singh. I am going to discuss one of the important topic of the machine learning technique, and the subject code is BCS 055. And why this topic I have chosen today for the lecture, because this topic is very important in the machine learning, and because machine learning is divided into two different category. First is the supervised learning and unsupervised learning. So supervised learning, where you are going to take the data in the label data, and we will train the model, and we are getting the same output. But in the unsupervised learning, we are capturing the data that is imbalance, that is not labeled, and we are giving to the machine, and machine will be categorize the data in respect of the size, type, and color, texture, on the basis of all the types of the data that can be categorized by the machine, and machine is giving the output. So, but in unsupervised machine learning, we are not training the model, but in supervised learning, we are training the model by the label data. So this is the topic that we are going to discuss about the why we have chosen this topic, that is Bayesian network, Bayesian learning. So Bayesian learning is an approach to machine learning that uses Bayes theorem, because Bayesian learning is work on the Bayes theorem to model and update the probability of the hypothesis as new evidence become available. So what is new evidence? On the basis of that, it will work by the model, by the theorem, and giving the output. Bayesian learning treats model parameter as probabilistic rather than fixed value. So because it will work on the probability, either how many chance of this occurrence of this model, but it is not giving the result in the form of the value. Like we are going to predict the house price prediction. So house price prediction means we are giving the input value like in the size, length, and breadth, and on the basis of that we are going to calculate the size of the house, price of the house. So size is calculated by the dimensions, and by using the dimension we can calculate the price of the house. So this is the value based. But in case of the Bayesian theorem, Bayesian network, we are not predicting the value, but we are predicting the probability, how much chances to become this and how much chances to not become this. So this is the probability based. Maybe the value is range from the 0 to 1. So this is the probability value. So maximum probability is 1 and least probability is 0. In other words, Bayesian learning is a probabilistic framework, and for updating our belief about the model parameters based overall data, because we are giving the data, and on the basis of the data we are predicting how much percentage your model is giving the accurate result, how much percentage your model is giving the updated result. So on the basis of data, model is collecting the data, we are collecting the different sources of data, and we are going to pre-process the data, because pre-processing is very important part of the machine learning. If you are not going to pre-process the data, it means that we are not going to clean up the data. So clean up the data is very important, because our data is having the different types of impurities in the form of the redundancy, in the form of the inconsistency, in the form of the null values. So we will clean the data. If you are going to clean the data is clean, then you will send that data to the model. You will train the model. Either what model you are choosing, either you are choosing the different machine learning model. Maybe your model can be a supervised technique, maybe unsupervised learning. So we are going to choose the particular model for that particular data. On the basis of your model is giving the output. So your output is in the form of the percentage, in the form of the probability. How much percentage, how much accurate your model is predicting. For example, we are collecting the data from the software project, and we are pre-process the data, and we are transfer that data to the machine learning. What technique we are going to use? Your model is predicting the defects from the particular software project. So how much percentage your model is predicting about the defect, that is important, because we have categorized the data, whole data, into the two part. One is training part and second is testing part. Training part means we have trained the model 80%, test the model 20%. Yeah, or you can use another way, 70% training and 30% testing. So on the basis of that, you have divided the whole data into the 70-30 या 80-20 ratio, and on the basis of that your model is predicting the accuracy, predicting the value, that predicting the probability. This model is predicting the 30%, 70%, 80%, 20%. How much accuracy is given by that model? This model is predicting this type of defect is there in the software. So that is the important. So that type of approaches used by the Bayesian learning, a Bayesian theorem, that work on the probability. So this is the formula we can see here. The probability, if you are going to calculate the probability, so probability PAB, AB slash here. So PBA into PA divided by PB. So we are going to calculate the probability. What probability we are going to calculate? We can calculate by putting the values. So what is PAB? That is posterior, the probability of event A happening given that B as a occurrence. A, how many times A is going to occur out of B. Similarly, how many times of B is occur on the basis of A. The probability of observing event B given that A is true. So how many occurrence of B in A. So what about the PA? PA is a prior, the initial probability of event A before seeing evidence of B. Similarly, what about the PB? Evidence or marginal likelihood, the total probability of observing B regardless of the A. So this is the concept of the probability. If you are going to calculate the probability, then you can use this formula and you can calculate the probability. So now we can calculate the probability by PA slash B. You can write down in the formula of P intersection B oblique PB. So what is the common between A and B? That is probability of P intersection B and divided by total probability of B. Similarly, we can write the formula P oblique A, that is A intersection B of P and divided by PA. So this is the formula where we can calculate the probability value by using the Bayesian theorem. What are the technical theorem terms of the Bayes theorems? That is Bayesian theorem. That is, first is the hypothesis and second is the evidence. Hypothesis means how much your model is predicting, this amount of result you can capture by using this model. So that is the hypothetical. Hypothetical means your model is predicting the hypothesis value on the basis of the data set, on the basis of the previous experience. So here posterior denotes that we need to find the probability of a hypothesis given that either the data is provided or have observed some evidence. That is the PAB. In the terms of the likelihood, probability of evidence given in that hypothesis is true. So if you are going to calculate the probability of PA or probability of PB, so how many times occurrence of A and how many times of occurrence of B in the form of A union B. So A union B means total outcomes is A union B, and in that particular outcome, what is the occurrence of A, what is the occurrence of B. So it depends upon the occurrence of A and B among the total outcomes A union B. So this is the conditional probability and independence probability. We are not going in detail, but probability is going to calculated by either PAB by equals to PA into PB, or PAB is equals to PA intersection B oblique PB. So it will depend upon the how many hypothesis is occur. Like we are going to calculate A. So A is occurring this amount of true value, B's occur this amount of true value on the basis of how much total occurrence. So A union B is the total occurrence in which we are going to calculate the PA and in which we are going to calculate PB. So on the basis of total occurrence. So this is the formula in which we are going to discuss about the product rules. Let's say probability. They say like P and B of a conjunction. So conjunction and disjunction, there are two formula, two types of the variables. We are using the discrete mathematics. So P intersection PA and B of a conjunction of two events, event A and event B. So how many times event A is occur, how many times event B is occur, and P and B, what is the common event between A and B? We can calculate by using this formula, that is conjunction. Similarly, for the P or B, means how many times PA occur, how many times PB occur, and minus P intersection B or P and B, you can just minus what is the common value of P, A and B, because A and B are two different events. Then you can calculate P, A or B. So this is the formula where you can calculate like this one. P, A or B means PA plus PB minus P and B. So you can calculate this formula. Similarly, we can calculate this formula, that is Bayes theorem. The posterior probability PH oblique D of the S is given, because H is given and D is total values. So we can calculate by using the PH oblique D, where we are calculating the hypothesis of P D by H and total of occurrence of D, that is P D. So this is a formula where you can calculate the occurrence of A, occurrence of B by using the conjunction, by using the disjunction. So on the basis of that, we can calculate the probability value of the theorem. Now we are going to take the example, a certain diseases affected 0.5% of the population. There is a test for this disease. So how many times of occurrence of disease about the population? So like we are going to take an example, 0.5% of the population diseases occur. The test correctly defined those with the disease 95% the times sensitivity. How many times we are not affected by the disease? That is 95%. So 0.95 is converted into the percentile, that is 95%, and 5% means we are taking the value out of 100, then 5%. If you are taking the value in the form of the decimal value, then we are taking the 0.5, 0.95. You can write down this formula. So this is the two value where you can take the example. Maximum and posterior hypothesis, I have discussed about how you are going to calculate. So in many learning scenarios, a learner considers some set of the candidate, that is hypothesis, that is denoted by capital H, and is interested in the finding the most probable hypothesis. H belong H. So H is number of hypotheses that can be occur, and H is total number of hypothesis. So capital H is total number of, or how many times of the hypothesis can be occur, that can be shown by the small h. So small h is belong to the capital H, is given by the observed data D. So data D is a data set. D is data where H is occurring and H is total hypothesis. So by using this formula we can calculate. So any such maximal probability we can calculate it by the formula like maximum up posterior, that is MAP hypothesis. So it is shown by the figure. It is shown by the equation. So what is this equation basically is showing that the how many argument maximum, just argument maximum, H is a hypothesis which is occurring, capital is total hypothesis, and similarly we are taking the different phases of the formula. Here we are taking the PhD, D is a data set and H is the occurrence of the hypothesis. Similarly we are taking second phase, we are taking the D is a data set and H is the occurrence. And similarly, what you are going to calculate? We are going to calculate the pH. So by using this formula, we can calculate the maximum a posterior hypothesis. Ki how many times a argument can be occur and how many times a argument cannot be occur on the given data set. Maximum likelihood. So in likelihood, we are going to calculate the same way, but the formula is going to change. So in this, we are taking the value hypothesis can be represented by H is a equally probable, probably prior, and can be shown by this formula PHI and PHJ. This value can occur equal to each other when I and J are common. When I and J are both are common, then PHI equals to PHJ for all HI and HJ belong to the H. So H is total, HI is one part of the hypothesis, J is another part of the hypothesis, and both are belong in the H. When HI and HJ are equal, then you can say this is the likelihood hypothesis. So this case can be occur if two different events, they are occurring in the same way, then you can use this formula. Naive-Bayes algorithm is a supervised machine learning algorithm which is based on Bayes theorem. So Naive-Bayes is work on the Bayesian theorem and used for the solving classification problem. So classification and regression, there are two different types of category of the solving the problem by using the probability theorem. So classification means we are going to classify how many data is defected and how many data is not defected. On the basis of that, we are going to classify how many. So it will work on the probability, but we are not going to calculate the integer value. Like a regression is calculating the value. Let's say we are going to calculate the house price prediction. So house price prediction can be calculated by the value. We are going to find out the area of the house. On the basis of that, we are going to calculate the cost of the house. That is house price prediction, and that is depend upon the integer value. But in case of Naive-Bayes theorem या Bayesian theorem, it will work on the probability, the value that can be ranged between 0 and 1. So this is the example of Bayes theorem, Naive-Bayes theorem. So we are taking one example, a set of 14 training example of the target concept play tennis, where each day is described by the attributes outlook, temperature, humidity, and wind. So there are different categories where we are going to play the tennis. Somehow the temperature is not up to date, then we are not going to play the tennis. Temperature is up to date, we are going to play the tennis. So it can be depend upon the temperature of the atmosphere. On the basis of that, we are going to calculate the value. So this is the example. How many times of sunny is occur? So 1, 2, 3, 4. So 4 times sunny is going to occur. This is the value of sunny hot. Sunny means hot. And how many times of cool is occur? Cool is occurring here. This is the cool. Similarly, how many times of mild is occur? So we can calculate here. So we can calculate on the basis of counting of the temperature, how many times of hotty, how many times of mild, cool. So on the basis of that, we can calculate the value in the base of the probability. So these are the formula. We can calculate the answer, like how many people they are play the tennis. So 9 divided by 14. How we are going to calculate 9 divided by 40? On the basis of the sunny. How many people they cannot play the tennis? 5 divided by 14. Total outcome is 14. On the basis of that, we can calculate. So this is the formula. We can calculate and solve the problem. What about the Bayesian network? A Bayesian network is a probabilistic graphical model which represents a set variable and their conditional dependencies using a directed acyclic graph. So by using the acyclic graph, we can calculate the value of the Bayesian network And Bayesian network is another most important machine learning technique, generally work on the Bayes theorem, and the value is going to predict by in between the 0 and 1. So this is the example of the Bayesian networks where we can calculate the graph. So a graph having the node, that is root node, child, subchilds. So if you are going to calculate the node value, so it depends upon the how many childs are created by that particular node. Yeah, how many childs are connected to that particular node. So we can calculate the node value. So this is the diagram where we can take node is here, node is here, node is here, node is here. So there is 4 nodes, they are interconnected to each other, and we are rotating from starting from A to B, B to C, but we are not in rotating it clockwise in a cycle, starting from node A to D and D to C. So it means that B and D, they are depicting to the pointing to the node C. So node C is a merging node where we can pointing. So this graph is basically, if you're going to calculate the depth of the height of the this graph, so we can calculate label. This is the label, this is the label, this is the label. There are 3 labels. So label 0, label 1, label 2. Similarly, we can calculate by using the Bayesian theorem by joining 2 graphs. So in the previous figure, we are starting from the node A, reaching out to the D, reaching out to the B, and finally we are reaching out to the C. So this is the joint node, they are focusing on the value C. So similarly, there is a different examples of the spiker rain. What area is affected by the rain, what is not affected by the rain. So on the basis of the humidity or temperature, on the basis of your model can predict either this day can be rainy or not on the basis of the value. So sprinkle rain, glass weight. So divided the sprinkle rain in the 2 category: false, false, true, true, false, false, true, false, true. What is about the grass weight? First part is the true. So how many percentage of the value of the true? 0.0, 0.8, 0.9, 0.99. The value of this one is the true, and this is the false value, because false value is ranging from depending upon the true value. If true value is increases, false value is decreases. So these are the some examples of the Bursley alarm. So by using the Bursley earthquake alarms, means earthquake occur. Where is earthquake occur? How many chance of the probability? How many chance of the probability of B? So it depends upon the call. John call, Mary call. So these are the probability. John call and Mary call, these are the true outcomes. TT, TF, FT, FF. We are taking the PA 0.95, 0.94, 0.29, 0.000001. These are the outcomes depending upon the B and E. B and E are 2 different events, and we can calculate. Why Bayesian network is important? Bayesian probability represents the degree of belief in the event, while classical probability deals with the true or physical probability of an event. So Bayesian probability is another type of probability that rectify the frequent occurrence of that event. It is not totally deals with the true or false. Second point is handling of the incomplete data set, because this technique is work on the data set. A data set we are collecting from different sources. and we are training the model and testing the model. On the basis of that, we can predict the percentage outcomes. Learning about the causal networks, facilitating the combination of domain knowledge and data. Next point is efficient and principal approaches for avoiding the overfitting of data, because overfitting means sometimes your model is giving more result, yeah, good result from your expectation. You are expecting 80% performance, but your model is giving 90% or 95% performance. It means that this is overfitting. What about the underfitting? In underfitting, you are expecting the result 60%, but your expectation is fail, and we are getting 30%, 40% outcomes. That is underfitting. So underfitting and overfitting can be occur in the due to the data set. If your data is not properly clean, not properly pre-processed, then your result is vary. So that can be occur by using the different techniques. So what is the limitation of Bayesian networks? Typically require initial knowledge of many probabilities, quality and intent of prior knowledge play an important role. So you have the knowledge about that the event, what event you are going to play. So on the basis of that, we can calculate the probability. Significant computation cost, that is NP hard task, can affect. Unanticipated probability of an event is not taken care of. So these type of event, if occurring, these are the limitation of the Bayesian networks.